Did you know the Australian continent contains virtually all known rock types from nearly all known geological time periods? The oldest rocks in Australia are also some of the oldest in the world, increasing in age as you move from east to west. The area we're focusing on today is the land beneath our very feet, and whilst to some of the youngest parts of the Australian continent, is still in places over 23 million years old. The Great Dividing Range, whilst a significant landmark of the East Highlands, was actually formed 300 million years earlier during the Carboniferous period due to tectonic upheaval. During the Cenozoic era, the Australian continent moved northward, and as it did so, it passed over volcanic hotspots, spewing magma onto the flat plains, transforming the landscape further to create the Eastern Highlands and the geological structures like Eber Falls and Mount Kosciuszko, the oldest being further north and decrease in age the further south you go. These structures form what is known as the Great Escarpment, which erode valuable minerals and nutrients into the Eastern Highlands and coastal plains.
Southeastern Australia includes New South Wales, South Australia and Victoria, and is located in the southern hemisphere right next to the South Pacific Ocean. The latitude and longitude coordinates of South Australia is 30 degrees south and 136 degrees east, and in Victoria they are 37 degrees south and 144 degrees east. This is the approximate difference between the two locations in southeastern Australia. The entirety of Australia is moving in the north to northeast direction, differing from approximately 50 million years ago when Australia was moving in a northwest direction. This occurred because of a major change in tectonic plates. Australia sits on the Australian plate, which ranges from Coco Island to Western Noumea and south of Australia. At the start of the Cenozoic era, southeastern Australia was located in the southern hemisphere and close to the South Pole. This is because Australia had just separated from Antarctica due to the continental drift. In the later stages of the era, Australia was moving gradually north close to the equator. This was occurring due to the tectonic plate movements and hotspots. Australia had high volcanic activity due to the belt of volcanoes which was located in the eastern region of Australia, which had impacted immensely on the subjection zones and other geodynamic processes. Between the past and the present, there have been both positive and negative changes that has occurred along the east coast of Australia. From the Cenozoic era to now, Australia's geography has changed immensely, from the movement of the direction of the continent to the tectonic plate movement. The reasoning of this change is evident in climate change, which has negatively impacted on both the era and the present geographical features as seen in both the vegetation and the organism.
As Australia entered the Cenozoic period, the ocean separated it from the Antarctic continent, and the warm currents that once heated the continent were replaced by cold currents arising to a cooler climate in the southeast of Australia. As the continent also experienced a geographic shift toward the equator, the climate systems of the north and south were separated by a high-pressure belt that brought westerly winds and with them moisture to the southeast lands. The climate of Cenozoic Australia was defined by the shift from a warm and dry land to the cool temperate climate that we feel today.
Australia's southeastern coast looked very different just 126,000 years ago in the Pleistocene. The Pleistocene occurred in the same period, era, and eon that the Earth is currently in. However, the same geographic coordinate would look unrecognizable across the two time periods. During the Pleistocene, the southeast coast of Australia was approximately 4,000 kilometres from the equator and twice as far from the South Pole. Annual temperatures were up to 10 degrees colder than conditions today during the Pleistocene. The climate cycled between cold, dry icehouse conditions and warmer, wetter greenhouse phases as polar ice caps waxed and waned rapidly. During periods of icehouse conditions, sea levels fell dramatically to 110 to 130 metres below current levels as glacial conditions arose. The Great Dividing Range also saw the rise and retreat of both glacial and pre-glacial conditions during these fluctuations of climatic conditions. Dry glacial conditions prevented water from cycling, bringing large droughts. Temperatures rose during the upper age of the Pleistocene, with greenhouse conditions prevailing. Precipitation levels gradually increased on the southeastern coast of Australia during the Upper Age, bringing a flourish in vegetation growth. Patterns of grasslands and deserts, however, continued to change frequently as conditions continued to fluctuate. The Pleistocene can also be characterised by the boom of megafauna in Australia, including species such as Diprotodon and Megalania. Thousands of megafauna fossils have been excavated from Narrow Court in South Australia. Evidence of the first anthropogenic activity in Australia can also be seen in the fossils from the Pleistocene. Falling sea levels formed land bridges, possibly being the key factor that would allow humans to travel from Southeast Asia to Australia's shores.
The area we studied was once part of the megacontinent Gondwana. before splitting and moving southward due to continental drift, moving in the same direction today by approximately 2.7 inches each year. The southeastern coast of Australia is known to be the most populated area of the country, as well as being a hub for tourism, further increasing the anthropogenic activity. Climatically, the southeastern coast is fairly temperate, with hot weather cooling at night during the summer and cooler temperatures accompanied with increased precipitation in the winter season. Precipitation levels remain low and assume a slow drop, with the recorded average rainfall last year measuring out to be 11% below the rainfall observed in 1961 to 1990. Lack of rainfall, along with structural features of flat lowland, has caused for the climate to dry out, becoming more prone to droughts, particularly inland. Low-watered manning flora have particularly thrived in unurbanized areas, with sclerophyll forests dominating majority of the land. Exotic species become more commonly seen in more populated areas, particularly residential gardens.